Now let's go with this one, shall we? Anyways, so the plan for today's stream is pretty much the same as the first part will be the same as the previous one. So we gotta check how the new direct access for the trades for the chunks actually works. Oh, come on! Oh, damn it! Come on, you gotta focus on me. All right. So the first part will be checking out the performance for the next upcoming features, which actually deliver the near to for loop should deliver near to for loop performance, yet are quite versatile and useful. And the next thing will be discussing some of the plans for some of the future releases and our part, our plans as a product. And yeah, so the networking tutorial, it has to happen today since we're essentially getting lots of feedback on how to set up this thing. It's not really difficult, but the manual can be quite confusing. I understand that. Gotta update it also, but mainly, yet again, focused on the features and perhaps not the best strategy. But yeah, I gotta deliver some of the stuff that's actually missing or can be improved. So we get, like, all of us, because all of us are using the tool, gotta have the best experience, like, in the industry, not only for Unreal Engine. So gotta deliver this as well. And let's go, shall we? All right. Yep. Let me just validate our new user. Maybe make an episode of new people coming up. Mackerel. Yeah, by the way, если кто-то слушает на русском, задавайте вопросы на русском, буду отвечать и так, и так. Yeah, so if anyone is actually listening in Russian, I can answer in Russian as well. Yeah, so make a roll. Welcome to the club, Mackerel, and everyone else, essentially. So let's go. Let's go with this one. Yeah, and what shall we actually start doing first? Yeah, debugging the Unity build, got a non-Unity build, gotta fix this one before packaging the project. Is essentially the new release again. It's like almost ready. Just gotta test it to the bone, so so you don't have to, basically. And well, let's actually begin with the networking tutorial, because maybe people will get to this stream by googling stuff and they really want just a tutorial. So let's do this. What shall I do? I'm just essentially going with copying my project. Oh, better yet, creating a new one. Yeah, let's just create a new one. Let's make it from the starts. It's for 27. Yeah, the 5.0 release is essentially now available. So we're going to release the official package, not the repository-based folder stuff. How can I... Where is the chat? Chat is gone. Oh well, anyways. Now I need to... Where is the chat exactly? I'm only seeing this thing. Is it chat? No, it isn't. Come on. Can I actually refresh it or something? Tools, view. Oh, come on. Forget about it. Let's go with the tasks. Launching the editor, right? Let's just start with some template. Basically, a blank would do, I think. Yeah, let's just start with the blank one. And with the starter content applied, no need for this one. We're going the C++ way, just in case. Still can create a blueprints if we need, but yeah, essentially a better option generally. So let's call it, we have to put slash here, and let's call it Apparatus Networking. And surely we will make this final product be available for everyone for downloading purposes. But anyways, let's get it done step by step. And again, if we are talking apparatus, we're always talking data-driven, data-oriented stuff. So we are not exactly replicating the necessary like data blocks, like the Unreal Engine's way of essentially introducing new properties, the replicated ones. We don't do this stuff anymore when we go in apparatus. We're always going data-driven. And what this essentially means for us in this particular case, that means we're actually having to create some traits. Yeah, so let's just say this thing as a networking test map. Essentially an empty map here, just to kickstart the stuff that we are going to be doing. And let's create a trait. Oh, it's too loud here. Let's create. Come on. Let's create 1 2 2 2 2. Yeah, let's create a trait. You stole the chat. You stole the chat. Yeah. Well, you gotta give it back if you want some feedback, you know. Oh, damn it. I'm not going to like relaunch the stream. Better just switch windows here. So these traits are like transactional data pieces. And what can they actually do in real life? Well, they can actually be orders. The orders that you're sending from the client to the server to make some action. Those, for security reasons, should not actually be the state of the player, the actual state, because pretty much if you're going to send positions from the client to the server, this may actually need to be verified in order to be applied, because basically you can teleport this way if you're just going to send the position from the client. Now, you usually send actions, and not even actions, but requests for certain actions. So, for example, you can send a trait which tells the player is willing to jump. Or if you're making a strategy game or maybe an RPG, you should be sending. Let me just mute this stuff. you should really be sending some kind of task, or let's say a command to maybe um, for the unit to reach its target point. So the server can actually create a path for it and just move it along this path. So yeah, so some kind of request, some kind of orders, some kind of wishes from the client. And let's just create a trade. We're going the blueprint way for now. It's essentially the same for C++, but yeah, let's create a trait. Let's call it, well, let's call it wish A, or maybe let's call it client wish. So this trait is essentially client only. It should be sent from the client logically. And what's the noise? Oh, and what is the actual feedback from the server? Well, yeah, if we are going with this strategy or RPG example, it should be like the actual state for the game entities, for units, for example, and it should be their positions changing. We're not going to talk about the some kind of a lockstep approach here, so just syncing the data, raw data, every time it changes. So for the units, it should be a position, maybe a position changes, maybe some kind of events that are happening on the server. So a unit taking damage could be an example of this one. And yes, so essentially stuff like that. And let's call it, let's create a new trait. So every use structure is essentially traits in Apparatus, and let's call it server event. Let it be just generic name. And so what about the data on these traits? What actual data can be there? Well, if we are going with the client messages, um, because the Genie is kind of limited on the budget right now, so no free wishes, only one. And the state of this client request, it can actually be quite broad. It can have a type of the comment that it uses. Of course, you can create, say, a separate trait for each comment. So a trait for moving orders would actually have some kind of a vector here. So, for example, destination point, something like that. It could be. So a separate trait for maybe what can actually be done in strategies, but not moving. Attacking is essentially the same. Well, let's call it attack. Well, maybe a focused attack. So you right click on a unit, so it should be attack. So maybe some kind of a unit ID here. If it's attacking commands, unit ID, it can be like this one. And yeah, you can create a separate trait for each command. But you can actually create one trait for all of the commands, and it has to have some common fields like IDs, positions, stuff like that, just the bulk of them. For the simplicity's sake, say you don't want to mess up with multiple traits here. And you have to create some sort of identifier for this command. So you have to create enumeration Unreal's enumeration, which is basically a bunch of constants predefined. And let's just go with some standard one. Yeah, you can basically left, right eye, and you can define your own enumerations, and they can have lots of different values. They can actually be identifiers for the commands, so they can state that this command is actually um, move to command, and that command is actually attack command. So you can either go this way or other way. It doesn't matter. We will be going with some of the generic stuff. So we just make an integer and say its field is value, and yeah, a simpler approach just for the tutorial. But you can really go wild here. All sorts of requests, all sorts of constants, and all sorts of data can be sent from the client to the server. Yeah, so this is the client wish. And we wish the server could respond to it. So how shall we do it? Well, first of all, I'm just copying. Will be just copying my stuff. Let's just copy the plugins folder. Yeah, and this is not working. This is not required to do so. You can actually use your own bundled Epic Games bundle, Epic Library bundled plugin here. No need to go with this sources way, but yeah, it's still gonna work. I'll just close this stuff just in case. Delete these temporary folders. Now go in with the networking again. Let's just regenerate the codes. Nice. And yeah, let's launch it from the Visual Studio Code. It's better and more handy to do it this way since you can actually catch exceptions. Well, Unreal Engine doesn't use exceptions, so Apparatus is not using them, but some kind of crashes, it still can be debugged a lot easier here. Now we're playing with power, the apparatus power. So yeah, let's create our mechanism, shall we? This mechanism will be server only, so it won't actually be present on the clients logically. And essentially, it will receive the client wish. So let's create a folder. Let's call it server. So these are only server based. And now let's create. We can just. Why isn't this focused? Yeah, just go with the mechanical actor. And let's call it server mechanic. So these will work only on the server. You can actually use the game mode for this purpose, because the game mode is essentially server based. It's not going to be present in Unreal Engine. It's not going to be present on the client, but yeah, we're going with a separate actor and we'll be calling it server mechanic and just making sure that this thing is actually not loaded on the client. So this one is server only. This one is server only. And let's just make its logic. Its logic happening. Hmm. What exactly am I doing? I got to be creating. Oh well, the other way around. Let's create. Almost forgot about this one. Can I really? Yeah, I gotta create a separate blueprint of class. So yeah, server mechanic. This is it. Let's just move it this way. What? Yep. So, how would actually look its code? So we don't need these and these, only the chicken. And yeah, if we're going to the server, we can actually do this in a steady tick, and it may be actually wiser to go the steady ticking way, because the server really shouldn't be presentation dependent. But for the sake of simplicity, again, we're going with the standard Unreal Engine stick. And what shall we do this stick? In this stick, we're going with the mechanic, cause so the apparatus way, and we will be adding a pin, not this one, just adding a trade pin, and let's call it client wish. So the mechanic will again logically evaluate for all of the subjects which actually have this client wish. And so yeah, when the client is pushing its wish, it's assigned on the server's version of the client's entity. And we will be doing this a bit later. But what shall we do right now? So we will be just printing a message. So we are receiving this wish. Yeah, so this is client wish. Wish received. Yeah, so this client version will have a green color. The duration is fine, I think. Yeah, so we can actually break this structure pin and get it like to string and just concatenate actually format text. No, not this thing. How's this thing actually used? Well, the format is quite logical, but we need the arguments. Can you actually format with these built-in methods? Oh, anyways, let's just concatenate. Make string. Oh, damn it. Let's just append this one. And then, yeah, so again, we will be just printing the message here, the wished with its like hash value with its unique identifier. Yeah, yeah, yeah. That's a nice one. Well, yeah, for now it's only binary messages essentially, but we could easily send JSON if you think it's worth investigating. I can do this. It's totally doable. Yeah. So yeah, this is basically our server mechanic, and it's pretty much done this way. So server receives a message. It's print. It's printed in the console, and that's basically it. And now we're going with the client code. So at this point, we should really be creating a custom player controller. Yeah, the controller that we will be using in this game mode. So let's create. Um, is there actually always forgetting of the stuff that's well anyways player controller, and let's call it client controller. And those things first. So this controller is absolutely this controller absolutely has to have certain things. And the first one is the subjective component. Yeah, so let's create subjective component. So this thing essentially makes these subjective and subject. So every subjective is always a subject. Uh, and if the subject is present, it can have traits assigned to it, and it can also be networked. So it can have traits pushed to it from peer to peer. And that's what we are going to do. So yeah, we gotta check this one because the component will remain offline if we're not going to do this. So gotta set this one. And we also have to assign the trademark pass. This is an essential security feature that's pretty much blocking all of the non-matching traits. So for example, there is nothing that could prevent a client to send some kind of perhaps you have you have a game that's strategy or an RPG that has some kind of a money um, mechanic implemented. So it got some money data, money traits. For example, like the total sum of money that a player carries. And there is actually nothing that could prevent player himself to push this trait and say he has 1 million golden coins, which will actually ruin the game. It will make it insecure, and this is actually quite a breach to address. And this is basically addressed with this trademark pass field here. So here you list all of the traits explicitly. This is essentially a whitelist. So these traits can be received on the server. only these. Others by default are non-receivable, considered insecure. Because most of the time you will be creating normal mechanical traits, not the networking ones. You only create a couple of them, really. And you can create actually one single networking trait. All of them will be just fields in it and have a type value assigned, for example, like I've showed you before. So yeah, let's create a list element, and let's choose the client wish here. So the client wish now is accepted on the server. The player controller is a special kind of actor, which is present both on the client and on the server. So each player controller instance will be created on the server as well. And we need to be sending a client wish. So let's just send this wish when we press, let me check. Yeah, this should be, we have to create a new component here later, but anyways, let's just create some kind of a press. How to, yeah, let's call it space bar, and let's send it when it's pressed. Yep. And we have a subjective actor here, so we can just use it this way. And now let's just push extra trait. We're gonna be using the subjective version, of course. So the button, the space bar is pressed, and then we are sending this thing here. And the type is client wish. Again, quite logically. We can split this thing. And so we can, as long as we are in the player controller, we can actually get player controller ID and assign it here. So we shall be testing with multiple players. All right then, that should actually be it. So let's start and just check it out. If I did anything wrong, we'll be finding this. Later, because there's another component, but in this scenario I think it's not really mandatory just yet. So come on, we play as a client. Let's just play with two clients and go. Always try to save everything. Oh, really? Ah, it has created. Yeah, sure, it has created a new one. It's not set in the project. Gotta save it as well. Packaging, maps and modes. Networking test. All right, let's go. Oh. We should be creating a game mode. Just a game mode space, or a game mode would do. So let's create this one. Game mode is something else. Tick, 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 tick. So. Yeah, and the player controller will actually be the client controller. Sounds good. Now let's just start and see what we'll be getting. So, not getting much, but no worries. No worries. Yeah, I think we should be adding this thing right here. So this, let's just start once again. Come on. Not enough, really. So let's create a network pair. I thought it was not really important in this case, but maybe I'm wrong. All right. Spacebar. Yeah, pushing the trade. Oh, yeah, and of course, yeah, this would actually spawn and spam lots of client wishes. It should actually remove trade after it has already written to the console. This should be it. Come on. Really? So something else is actually off. The player controller. Well, let's check it out. Is this actually happening? So this indeed is happening. No. And no errors, really. Client wish state is not allowed to be pushed on the server's version of subjective actor. How come? How come? I think I certainly did. Oh, I didn't save it. Really? Really didn't save it? Really? Come on. Is not allowed to be pushed to the server's version of the subjective actor. Hmm. It's just It's just impossible. Why is it not saved again? Wait a minute. It's because I'm just setting these. No, the belt is actually optional here. The belt is only needed when you're dealing with bunch of details. It's an optimization, really. No, it's not about this thing at all. Yeah, I certainly did. And the trademark pass is there. And the replication is there. That's just a bit of a trash that's happening right in front of our eyes. Wait a minute, wait a minute. No, it shouldn't be. It shouldn't be this way. Come on. The funny thing that I've already tested this one before and it actually worked. I just missed something and I still don't get what 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 I've actually missed. So pushing the trade to subjective, which is actually the replicated one. Kicking is not really important. So these should be creating a bunch of player controllers. This one is here. Well, it should be replicated. It should in fact be replicated. So it should be created both on the client and on the server. You think I did it wrong? You think I shouldn't have to set it like this? Well, let's get to the reference one. Wait a minute. Oh, crap. Forget about that. This one is not here. Let's go and just copy this from the benchmarking code. Hmm. Mm-mm. The data section is an actual like state of things. So it's the current way, it's the current status quo for the entity, and it's not something that it should be. It should be runtime altered basically. So this data block is quite dynamic. It's changing. It's ever changing. Oh, well, we will be doing fine. Just need to set up like my tests did. Not working. I've checked this before. This is quite strange. So yeah, play as a client. Pushing the trades, yeah. Pushing the trains. trades works just fine. Now let's just check. So the world and the player controller, game state base, player states. This is basically an empty game mode here. So the player controller is here. Let's just check it out. So here, maybe this one is actually wrong. Maybe this one shouldn't really be set. Okay. Let's just then reset this one, compile, and go. Yet again. No, this is not the cause, or not the only cause. Player controller, pushing trades. Well, that's essentially the same. So these component replicates. This trade is set in the trademark pass. This one is basically garbage. It shouldn't be there. It should work still. Maybe this garbage actually meant something. Nah, it didn't. Works as planned. And the network pair. So just the ticks disabled, but it can't really mess up the things, but let's just make it so. But it shouldn't, like, come on, what's going on exactly? If it works there, it should be working. Really, it's pretty basic in the workflow terms. It's not. What? I just had to like reboot it and it suddenly worked. So if you get something like that, that's of course pretty weird, but maybe, oh, I don't see what's happening here. Maybe some kind of a memory actor issue. Maybe I was in the wrong world. Maybe I was in a temporary world that was auto-generated, which I've actually saved. I don't get it. Well, this works. Anyways, yeah, sorry for the mess. It wasn't because of the wrong setup eventually. It just didn't work. So these are wishes received on the server. Let's just go with this one. Oh, why is exactly the player controller ID is always -1? That's pretty strange. But anyways, yeah. So I'm gonna just hold this one. Networking test. Mm-hmm. Let's just check that everything is actually working as expected. Client wish value. Ah, the player is my player, of course. Get player, get controlled, get player controller, player index. Well, the controller has to have its own method. Get player. Mm-hmm. What's this thing? The controller has a reference for the pawn. Get controlled pawn, it should be. Yeah, yeah, that's the right thing. Get player. Mm. Mm-hmm. Yep. So let's try again. So this one is, yeah. So this one is ID 258, and this is 59. So this basically works. Yeah, and now we should be reacting on this wish on the server, and we will actually be reacting with an event, with the server event that we already created. It can actually not have much data here. It should be fine. Yeah, so let's go on to create a client only mechanic, the one that will always be present on the clients only. And let's call it client. Here, let's create a mechanical actor, client mechanic. It can play animations, things like that, depending on the server's responses, on the server's events. And how can we actually create this thing? How can we actually detect is the thing is running on the client? Well, it's pretty simple. We go in with the standard chicken event. Is client is client is oh, I forget about that. Let's just create. Always forget about this one. There's this get self. itself is, oh, forget about it. So again, is server is what? It's a C++ method. Ah, it's not, it's client, it's server. Oh, come on. Come on. So yeah, is server. Right. Nice. Now let's create a branch here. And only if this one is false, that means that we are running on a client. And again, a mechanic. Just adding a trade pin here. It's gonna be server event. Yeah, and just go on and say about it. Servers event received. Yeah, pretty much it. And of course, we gotta be removing this event, or else it's gonna be spamming all the way. Remove trade. Can remove it from subject, can remove it from subjective. Doesn't really matter here because the player controller is also a subjective. So let's server event. So this is our client-based mechanic. It won't be doing much now since the server isn't actually pushing anything to the client. So we have to go to this folder and edit this mechanic. While removing this thing from the subjective, we should be adding or pushing the trade to the subjective. So the subjective is again this one. So we are receiving a trade from a client, and we then remove a trade from, while removing the original trade, we add the trade, and it's server event trade. Yeah, we can actually split this one and color true. Yeah, so remove trade, push trade. It should be it. So let's check. There is no need to set the trademark pass on the client, since all of the trades by default are receivable on the client because the server is pretty much authoritarian. So let's go. Yeah. So yeah, the order is a bit different because of lagans or something, doesn't really matter. So we're going with the trades, and we're receiving this trade on the client, on both clients. So this gets propagated to all of the clients actually, like it of course should. So units position should propagate to all of the instances on every client. And that's basically how you do networking in Apparatus. Yeah, so any questions on this one? Of course, I will be uploading this project for your needs. It's pretty basic, certainly, but anyways, maybe it should help you kickstart your development. But essentially, yeah, essentially this. So just to wrap it up, you have to like create a bunch of stuff. So you have to make sure you're creating a player controller, of course. It should be having a subjective actor, which is set to be replicated online. And this subjective actor has to specify what kind of traits it can receive on the server from the client. And you also gotta be introducing the network bearer. It's the manager of the pushing of the traits from the client to the server, well, mainly from the server to the client, for the propagation on all of the clients and things like that. And so, yeah, when you push the trait from the server, if this is a kind of a subject that's not already present on a client, it gets created on a client also. So you can create, and you should be creating, for example, if the player asks to you to, if again you're implementing an RTS strategy game, and your player is creating a bunch of units, maybe the order for the server is to buy those units. So the server, in its server mechanic, checks if enough money is if enough money belongs to the player. If the check has successfully passed, it creates some subjects. It spawns them regularly with the spawn subject node. And first it spawns it on the server only. And you can bring this subject online. It's a server only method. You can bring this subject online. So every player in the world, every client, every remote peer gets its own version of this subject. It obtains a special network identifier for this subject, which uniquely identifies it across all of the available clients, peers, etc. And once it's online, it can receive traits. It can receive, you can push traits on it. And this is actually done automatically when you push an extra trait from the server. So when you do this thing, uh, this will actually bring, if you're doing this from the server, because client can't really bring subjects online for security reasons. It can't spawn bullets or something like that. Only the server can. So when you do this, this action is spawning those not yet online subjects on all of the peers, on all of the clients automatically. So basically, the as long as you've set up this thing, this player controller, everything else is pretty basic. You're only will be pushing traits from the client to the server, from the server to the client. And the the an interesting thing here is that the API is pretty minimalistic, really. So the only method that you will be using in order to synchronize your stuff the data-oriented way, then the only additional method is pushing extra traits. So pushing a trait for the to the server, or from the server to the clients. You can also set this trade for the local instance of the subject if you need. So if you're issuing some kind of orders from the client to the server, you most likely not be setting this check mark here. But if you're synchronizing your unit's positions from this server to the clients, you'll most likely be sending those traits back to clients, those positional traits to clients, and both will be setting those for your own local copy, local instance. Yeah, so let's wrap this up. Setting this setting up these player controllers right here, and basically, yeah, I think it's pretty trivial. And if you're like already thinking data, it should be pretty straightforward for you to implement even the most complex stuff here. And the good thing about this approach is that you're actually controlling all of the data that you will be sending. For example, if you think that a certain value, a certain entity, a certain subject is out of the visibility of a certain player, you can actually narrow down the scope of traits that you will be sending to the players. So you always will be controlling this stuff yourself. Um, you can also use all sorts of methods which are already present in the Unreal Engine for checking the state of the player controllers and stuff like that, like I did here, like querying the player state and essentially um, querying its unique identifier. So all of this stuff is actually present, can be used for some debugging purposes. So the whole system is basically based on an existing Unreal Engine's approach. So it's compatible with all of the stuff already created for Unreal Engine, including some kind of a Steam server capabilities or standards, Xbox and consoles and things like that. It's pretty like settled on native Unreal Engine's capabilities. And yeah, as of plans, I'm actually thinking about creating some kind of custom protocol for the ECS in order to be like very efficient in terms of traffic and data in future, but it's not really that easily set up in Unreal Engine. It has to be managed manually. It won't, of course, be compatible with all of the existing stuff for Steam, for consoles again, and it's pretty risky, but it still can be um, quite efficient. I mean, if you're making your own custom protocol just for the needs of the ECS, for our implementation in particular, of course, you can cut some really nasty corners, so to say. But of course, everything comes at a cost. We're still thinking about this one. And about the lockstep, and if you should be doing lockstep, you know what, if you're really going with the custom physics and custom AI and custom everything made in some fixed points or some other deterministic entities, um, you can be doing this way and utilizing the pushing of the traits. So you can just use the traits and the pushing mechanism for the event synchronization. So if you're going with lockstep, you essentially need to be synchronizing all of the client's input. And you can do this again. You can do this with the pushing traits capabilities. You only have to create a full deterministic stack for the for the for the functionality I was mentioned, so physics, AI, etc. and it can be quite complicated. And of course, that's our, I don't know, long-term goal to implement some kind of a general purpose uh, library for the for deterministic physics and AI, including the being able to be edited inside Unreal Engine natively and beautifully. It's still on my radar, so to speak, but it's certainly what's not coming like tomorrow. And what's coming on tomorrow, of course, I will be presenting you, let's say, I making some kind of um, well, need some things to be done. I didn't know that this would actually be so time consuming, but anyways, yeah, we will be going with the new features lately today, of course. Yeah, so basically, that's it for the first part of the stream. And yeah, coming up next this day for about 4 hours, I think, we will be going with discussing the actual new features that are coming into the new version of Apparatus. It's pretty significant, I must say. So stay tuned. I will be posting the links to the stream in the Discord. So yeah, keep it up, guys. Hope this stream was useful for you. And until next time, keep on apparatusing. See ya. Bye bye.